All right, this is my tutorial on how to design a 3x3 Rubik's Cube in Onshape. I would recommend you have some Onshape experience before this, but if not, it should be pretty easy to follow along. I would also recommend you change your units to millimeters, and let's just jump right in. So I always start by hiding the front and the right planes, and then we're going to make a cube, so start a sketch on the top plane. And then you're going to select center point rectangle from this drop down and make sure the origin is highlighted when you start it. And then we're going to make these two edge lengths equal to each other. And then we are going to make this edge length 57 millimeters. Confirm the sketch. Extrude the square into a cube, so 57 millimeters again. Make sure you check off this symmetric box so that the origin is in the center of the cube. And then we can, this is the final shape of the puzzle. So we're gonna start another sketch on the top plane. And it's probably good at this point to hide the top plane. And then we're going to make construction axes. So one of them is going to be the turning axis that we are gonna turn the cube on, and then the other one is just showing me where the centerpiece is for the other side. Now we are going to make another line. Make sure it extends far outward from the cube, and you'll see why in a minute. I'm going to make this 19 millimeters away because that's how big our cubies should be. And this needs to go through. We are also going to make another line going diagonally in like that. And I'm going to make the angle between these two lines 55 millimeters, because when you do a few trigonometry equations, this angle needs to be 55 millimeters when you're going through the middle for the cornerstock to be the way it should be. That might have been confusing, but it doesn't matter, just 55 degrees. So from this drop down, now I'm going to select center point arc, make sure the center is around the origin, come out to this point and come out to here, and then I'm gonna come here and then go right back. And then we're gonna complete it with a line here. And this is the general shape of a 3x3 sketch. I'm gonna make this vertical. You don't need to, but I like to, it looks nicer. I'm gonna bring this back actually. And I always make this, what's called a shell, 3 millimeters thick. And then this, I always make it at least 15 millimeters. So like in this case, if I do 18 millimeters, that looks perfectly fine to me. And I think for the most part, this sketch looks good for a 3x3. So now what we're gonna do is we're gonna select this revolve feature, and we are going to select every component of our sketch to revolve around this line. And now this is our cutting plane, or sorry, surface. And if I hide the part, you can see that's what that looks like. So now what we're gonna do is we're gonna select circular pattern from this drop down, and then I wanna pattern this surface, and then the axis. Now there's two things you can do. You can select an actual axis, such as the one you made in your sketch, and that'll work just fine. But what I like doing better is I like to select this, which is mate connector, and then select this center of the face, and it'll go around automatically like that. And then we need to do the same thing for the other face. So I'm gonna do the same thing on the other side, which then here, yeah, you don't want it to be here. You wanna make sure it is in the center of the face. And when I do it this way, there are like duplicate surfaces like on this surface, but that doesn't really matter because it just ends up being the same anyway. So now that's all the surfaces we need. Make sure in your sketch this point and this line are touching each other, and then also So you can now see that if this line were not as long as it were, the cutting surfaces don't go out far enough. Like this cutting surface cannot cut the cube. So you want that to be a lot longer. So it goes completely outward. Now we're gonna do the fun part. From here you wanna add custom features. And then if you look up at, here, maybe that's enough. Yeah, so if you go here, and you want this dice split menu tool. So I already have it, but if you click it, it'll say it's added to your toolbar. And then you go down here, and then you should have it. So for me, it's right here. Parts to dice, and you want to select the cube. And then surfaces, I hide the cube and select all of my surfaces. And then that's what you end up with. So now if you hide individual parts, or sorry, isolate individual parts like that, I always make sure that one, it looks like it has a valid mechanism, and two, the centerpieces should have room for a screw hole. So here I see 9 millimeters. That's plenty of room for a screw. The edge piece, that looks fine. I always make sure that this is longer than like 2 or 3 millimeters, and it's 3.9, so that's plenty of room. I see nothing wrong with this. So, and then the thing that you should be most worried about is corners getting cut off from their mechanism. But in my case, this is actually plenty of room. I am not worried even a little bit. So, in your sketch, a lot of the time, like if this number is too small, or if this is just way smaller than it is, like that, like the corner piece will get cut off from its mechanism in this case, which is not what you want. But if I just undo that, like this looks perfectly fine to me. So now I'm going to select these 3 parts and hide them. And then I'm also going to hide the core, which is just a sphere. And now I'm going to select this delete tool, and we're going to delete all of these because all of these are duplicates. And now I can just show what I have, and I can rename them. So this would be a corner. This piece is an edge. This is the center. And this is the core. So now you add clearances or tolerances. Depends on who you ask. And for me, I just imagine all of the faces that if I were to pull the part away from the cube, what faces would be stopping it from holding it in. So let's do the move face tool. And for FDM printing, I usually do between 0.1 and 0.3 millimeters for clearances. So I'll do 0.2 in this case. You select this face and make sure it's taking away material. Like Onshape automatically wants to add material, make sure it's taking it away. So on an edge piece, for example, I add clearances to these 2 faces and nothing else, because those 2 faces are the ones that hold the piece in place. And then we're going to do the same thing with the corner piece. So if I were to pull the corner piece out, the surface that's stopping it, the surface that's holding it in would be this face. So I'm taking away material from that face. The center obviously doesn't have anything that's holding it in place except for the screw, so we don't need to worry about anything there. And then I always add some clearance to the core just because. And that's good for clearances. The next thing you want to do is add fillets. So for what's called vertical fillets, the ones that point straight into the cube, such as this line, I like to try 2 millimeters. And for horizontal fillets, such as lines like this, I usually start off with 1 millimeter and see where I am from there. So let's hide other parts and start here. We're gonna say 2 millimeters, and then we're going to select all of these. All right, and that's all the vertical fillets for the centerpiece. I could probably even go bigger than that. Right, and then once I have those fillets, I'm going to do these again, but this time with 1 millimeter, and I'm going to select this one, and this one, and this one, and this one. And now that looks like a pretty good centerpiece to me. So now I'm going to do similar things with the other parts. So let's do the edge now. And start with 2 millimeters. And I'm going to do this one and this one. And a lot of the times fillets get mad. They do not like this. It kind of hates doing these sometimes. So sometimes you'll have to do them separately. So maybe I'll start with all of these first. Whoops, not that one. Not that one. These super tiny ones that I'm selecting show up from adding clearances, and they're not super important, but I'll do them anyways. Okay, and then I will do this again, but here. There we go, now it's working. Another general rule is that you never fillet concave edges. So such as this one, don't fillet this because that adds material, and also that happens. This, you want to fillet all of the convex edges. So there's, that's looking good to me. Is it gonna get, nope, that's working. All right, that looks good. And then I'm going to do 1 millimeter for here, and here, and here, here, here. Oh, here, obviously. I don't see anything wrong with this, except I'm gonna add another one because here, all of these, I like to add like a 3 millimeter fillet to that one. Those have nothing to do with turning. That just changes, like how sharp the puzzle is in your hands. So I think the edge piece is looking good now, so I can hide that. Corners are sometimes weird because a lot of the time, like if this corner stock is really thin, like this entire part will get cut off. But I'm not worried about that right now because my corner stock is extremely wide. So start with 2 millimeters again for these vertical fillets. And let's see if this one gets mad. It doesn't. Awesome. That's looking good. 1 millimeter for the horizontal fillets. And that. And I say that's looking pretty good. So now we're getting pretty dang close to being done. So now what you want to do is add screw holes and caps, etc. So I'm gonna hide other parts. So I want the centerpiece and the core, and view normal to the top. I'm gonna make a new sketch. Oh wait, actually I did it wrong. So what I'm gonna do is make a plane, an offset plane from this face, and it's gonna be like 3 millimeters offset and go into the part. That looks good to me. Now we are going to split the center with this plane, and that looks good to me. Hide the plane because we're not going to need it again, and I'm going to rename this one cap. All right, that's looking good to me. I'm going to hide the cap and make a sketch on this face. Now what we're going to do is we're going to make a couple circles. So make sure all of these are around the origin as well. So there's the one that the screw screws into, the one that the screw slides through, the one that the screw sits inside of, and then the one that makes a wall. Okay, and now we are going... all of these depend on what screws you're using, and it might take some trial and error to get good sized screw holes, but I always make the smallest one for the screws I use 3.3 millimeters, and then these that the screw slides through 4.4, these that the screw sits in 7.7, and then these can be like 9. That one has nothing to do with the screw, so like it just depends on what you feel. Actually, I might go like 10, make it thicker. And then I'm going to get all these out of the way. What I'm going to do is I'm going to make a square. And then I'm going to round off these edges. 3 millimeters ought to do the trick. And then that's good for that. So I'm going to extrude and make sure you select remove for this one. And then I'm going to say through all. And then the merge scope, it's automatically going to do this centerpiece because the sketch is on the centerpiece. But I also want to select the core because this is the hole that it screws into. All right, so that looks good to me. Now we're going to do it again. Remove, through all, show the sketch. And just this one. And we only want the centerpiece for this one. Do not select the core. So that looks good. Extrude again. This time for this one that the screw will sit in. Remove. And let's just see. So let's go like right around here. Let's do 6 millimeters. That looks good to me. All right, I think that's all right. And remove again. This one, 3 millimeters. This is for the cap. Okay. Now, I think that looks pretty good to me. So what I'm going to do is I'm going to hide those two parts and show the cap. And just extrude this one out. Whoops, wrong way. By... this one should be like 3 millimeters, but I'll do 2 just in case, because that's still plenty of room. I'm going to hide that sketch now, because I think that should look good. So now we have this part, and the part that it will sit into. And sometimes these don't fit together super nicely. Like sometimes they just won't fit in together at all. So I might do something like 0.1 millimeters and make sure it's taking away material, not adding. To all of these faces and that one. That'll just take some trial and error again. And then I think, oh, we're not there yet actually. What I'm gonna do now is I'm gonna show that original sketch and use these axes, because I can't use mate connectors anymore because there's no face right here for me to select. So I'm gonna do circular pattern, and it's gonna be a feature pattern. And the feature I want to pattern is the one that made this screw hole. So that one is going to be this first one. And the axis is going to be this line. and then it's gonna like get mad, it's gonna be confused, so you hit this reapply features, and then that'll be good for that. And then the last thing you want to do is, oh, there's no screw hole right here. So I'm going to do the same thing. Entities to pattern, that circular pattern. Oh, whoops, feature. Boom. Axis is going to be this one. Reapply the features, and that looks good to me. Hide the sketch. One of the last things I would probably do is chamfer the screw holes. 1mm is just fine. So now they look like that. That's just slightly easier to screw the screws into. Doesn't really matter that you do that. The last thing you would do is obviously either split for stickerless, or make room for tiles, or make a sketch for stickers. But this is basically all you need to do. Here, I'll just go over stickers. So we're gonna make a new sketch on this face and view normal to the sketch plane. We're going to hit, I always forget where it is. This one, this offset one. We're gonna select this face, and it's gonna go inward by 1mm. Come on. And then also, yeah. Well, that's annoying. Also here. This one's also going to be inwards by 1mm. And then the last one, sometimes, oh, never mind, that worked actually, 1mm. Lastly, I'm going to round off these where they aren't, so they're automatically rounded here, but I'm gonna not over here, so I'm gonna fix that. Make that, I don't know, 2mm radius. I'm fine with that. And then, actually, I'm going to, alright, those look good to me. To make stickers, you would then take this and export as DXF, and then just cut the stickers. And then for FDM printing, you can either select individual parts and export them. But what I would probably do, since I know all of this is good, is I would right-click this Part Studio 1 down at the bottom. It's slightly out of frame for me. And then I hit this export. So you would rename this as like cube or something. I always do STLs. Make sure this export unique parts as individual files is checked. And then, yeah, like all that looks good to me. So then I would hit export and then just get ready for FDM printing. So what I would do then is print 8 corner pieces, 12 edge pieces, 6 center pieces, 6 center caps, and 1 core. This has been a very basic tutorial, and you won't be able to design more complex things, but it'll definitely give you a good start, and you can design a handful of cubes with this knowledge anyway. And that's just about all I got. Thank you for watching.